Okay, this is the Geometry Unit 3, Lesson 3 video. And basically, this lesson takes all of the theorems we covered in Lesson 2 about the transversal line and switches them. So in the previous lesson, we were saying if these two lines are parallel, jump over here. Sorry about that. I don't even know. There we go. If these two lines are parallel and they're cut through by this other line, then we learned all of these relationships, right? We had alternate interior, alternate exterior, and all that stuff. So these would be corresponding angles, for instance, or we had, alternate interior and things like that. So what we were saying then is if we know the blue lines are parallel, then we have all these different things that we can say about the angles. So in this lesson, it's the opposite. Now we're saying if I look at a diagram and I notice, for instance, that the corresponding angles are congruent, then I can say the lines are parallel. So it's the exact opposite direction. So the relationship is switched around. So you'll need the theorems from the last lesson in front of you as you do this, because you're really just going to be relying on those things. And actually, for the most part, we're going to do this on the video together because there are two major proofs in this lesson. But like I said, there's really nothing new here. It's just applying it in a different way than the previous lesson. So let's go way down here. I can find it. So you can see there's a lot of proofs here. All right. So this would be an example. It says lines L and M are cut by a transversal. See that in our diagram here. We have line L, we have line M, and we have them being cut by the transversal line. And it says alternate exterior angles 1 and 8 are congruent. So we're saying, we'll go ahead and mark that. So we're saying that angle 1 is congruent to angle 8. So that's being given. All right. So we'll start with the first things first. We know the first row of any proof is always going to be our givens. So we're going to go ahead and jump in and do that. So our given, I'll write that down again, sorry. So given in this one is all the information listed in the first row here. Lines L and M are cut by transversal T. Alternate exterior angles 1 and 8 are congruent. So that's answer choice A. You see that right there. So answer choice A goes here. The reason is given. There's answer choice F. So you always know the first row of any proof, remember, is always, always, always the givens. That's always the first thing in a proof. So then we keep going. Then it says angle 5 and angle 8 are congruent. Okay, so they're saying angle 5 and angle 8. That's here and here. Okay, so why are 5 and 8 congruent? So you need to jump back to your notes and you need to go take a look. And let me bring up our notes from that lesson. Here we are. We had groups of angles that were congruent, supplementary, and then we had vertical angles. So the question is, 5 and 8, which angle pair relationship are they? So if I jump back over, I notice that 5 and 8 are together on the intersection. They're across from each other. So you need to be tracking with that and knowing that that is an example of vertical angles. And that's what we're looking for here. So angle 5 and 8, we need to decide, okay, there's a vertical angle relationship. So we look down in our answer choices. Let's see, there it is, G, vertical angles theorem. We go down, choose G. All right, now we see so far we've talked about angle 1, we've talked about angle 8, we've talked about angle 5. So the next statement should have something to do with angle 1 and 5 because we've said 1 is congruent to 8 and 5 is congruent to 8. So naturally, the next statement should be 1 is congruent to 5. So that's answer choice B. Because that's the only one of these that makes any sense. It's only one that relates the angles we've already related. 1 is congruent to 8, 5 is congruent to 8. Therefore, 1 is congruent to 5. And the reason we know that is what we call the transitive property of congruence. The transitive property of congruence says that if two things are congruent to something else, then they are congruent to each other. And then we are applying the converse of the corresponding angles postulate, which says that if you can show that two corresponding angles, in this case 1 and 5, are congruent, then you can prove that the lines are parallel. And I could run up here to show you where it says that, but I will put a summary of all these converses. Here it is. If two coplanar lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. And we just proved that 1 and 5 were congruent. Since we did that, we can use the corresponding angles postulate, which is right here. It says under the reason, to prove that line L and line M are congruent or parallel. All right, so that's that proof. Scrolling down, you have vocabulary. Each one of these vocabulary comes from one of the little boxes up top where it has the different converses. So you need to just use those to answer 2, 3, and 4. Shouldn't be too hard. Just go up there and find each one and find which one matches the language you see here for 2, 3, 4, and 5. So those boxes, and I'll put them on the notes, are going to be those converses of the theorems are going to be the things you use to answer 2 through 5. Now we have number 6, another proof. So I'll do this one with you. It's a lot longer. It says lines L and M are cut by a transversal. We see that again in our diagram. Angle T is supplementary to angle 8. So this angle and this angle are supplementary. They already put that one down. That's our given. And then they say angle 2 and angle 8 equals 180. You should be thinking, well, that's what supplementary means, right? Supplementary means that they add up to 180. You're right. And so then that should tell you that for number 2, for the reason, we should be looking for something about supplementary. There it is, definition of supplementary angles. We said they were supplementary in line 1. Well, the definition of that is what we see in line 2. So we say, what was it? Definition of supplementary angles was answer choice D. Angle 6 and angle 8 are linear pair angles. Okay, we see that. 6 and 8 are linear pair. That's this angle. That's this angle 6 right here. Those are a definition of linear pair. That's just saying a linear pair is anytime you have an angle like this, you have these two angles, those are a linear pair. So just applying that to this diagram. And then the next one says linear pair theorem. Well, we should know what the relationship between a linear pair is. And that is that a linear pair, 6 and 8 in this case, are going to also be supplementary, which is what we see in answer choice G. We know that because they are a linear pair, they are also supplementary. Answer choice G. Then it says, therefore, angle 6 plus angle 8 equals, and since we just said they were supplementary, we know that supplementary means 180. So that's going to be 180 is right there. So that's going to be our answer for this one. Now, we've done two things right here. We've said, first of all, angle 2 and angle 8 equal 180. And then we said angle 6 and angle 8 equal 180. So if they both equal 180, then we can say what we say in number 6, which is that if angle 2 plus angle 8 is equal to angle 6 plus angle 8. So that is just substitution, F. Anytime you kind of combine equations, you're looking at substitution. Next one. Subtraction property of equality. That means I'm going to subtract the same thing from both sides of the equation here. Well, clearly it's going to be the measure of angle 8. I'm going to subtract the measure of angle 8 from both sides. They're going to cancel. And it's going to leave me with angle 2 is equal to angle 6. Answer choice I. Then I take that, and since they are equal, then they are also congruent. So then that's the definition of congruent angles. And because 2 and 6 are congruent and they are corresponding angles, then angle 2 and angle 6 prove that the lines are parallel, and that's what you have in number 9. So make sure you go through these proofs along with me here on the lesson. You answer 2 through 5 using the theorems from the lesson, and you're done with lesson 3.